Okay, so let's begin. Thanks for having me. It's really nice to give this talk. Uh, my name is Guilherme. I am a PhD candidate at the Museu de Zoologia at the Universidade de São Paulo, back here in Brazil. And today I'm going to present to you something that I've worked on the last few years on my master's project. Uh, let's talk about the Phloeidae, what we already know about this amazing group and where do we go from now on. So let's begin with the what do we do? I think that makes a lot more sense. So Phloeidae comprise three species divided into two genera, Phlea and Phleophana. They are very nice, beautiful looking bugs. They have several shining spots. They are large, reaching between 2 and 3 centimeters, and they exhibit some remarkable behavior. They are masters of camouflage, so they disguise themselves amongst lichens and mosses and barks of the trees where they live. Uh, they also exhibit some gregarious behavior. So sometimes in the same tree, you can see dozens upon dozens of nymphs and adults all together. The females also exhibit some maternal care, so they cover the eggs with their own body, and they also carry the first instar nymphs on their venter. The family can be recognized by some remarkable characters, such as the flattened body, these expansions in the head, pronotum, wings, and abdomen. Also, their eyes are divided into dorsal and ventral portions. Their shields are near the lateral margins of the metathorax, and the antennae are three-segmented, a character which is not very common among pentatomoids. As I said, they are a small family with three species included in Pentatomoidea, and they are restricted mainly to Brazil, but they are also found in northeastern Argentina and also in French Guiana. And their ecology and behavior are well studied for the past few decades, with several works dealing with their behavior, maternal care, chemical ecology, and so on. Many authors include also a fourth species within Phloeidae, Cerbana borneensis, a monotypic genus from Borneo. Uh, and on the other hand, some authors include this genus in Pentatomide. This is Cerbana, for those of you who have never seen it. They are very similar in the sense that they are flattened, they are large, their eyes are also divided into two portions. They also have the expansions on head, pronotum, wings, and abdomen. However, their antennae are four-segmented instead of three-segmented. The classification and relationships of the Phloeidae are virtually unknown. We do not know whether they are related to Pentatomid, to any other families within the Pentatomoids, and most phylogenetic hypotheses to date have not included either the neotropical species or Cerbana, or neither of them at all. The most recent work was the phylogeny of Pentatomid with molecular data, which included some Phloeidae from South America and Cerbana, and in this work, Cerbana was recovered within Pentatomid. So when we began this project, these questions were what motivated us to try and elucidate more of these relationships among the Pentatomoidea. However, when we started visiting collections, asking for photos of collections all around the world, we saw that most specimens did not have identifications, that several of the identifications were wrong, and that many times the Phloeidae, despite being large and beautiful, were scattered across the miscellaneous parts of the collections. So we saw that maybe their identification was not as trivial as we initially thought. We also detected some long-lasting taxonomical problems. Here I show you two publications from more than 100 years ago. And that left us with a series of questions which expanded what we initially thought to do in this project. So the identification of the species was a lot more complicated than what it seemed to be. Their distributional data was scarce, to say the least. Some publications listed them being found in South America, which is not exactly helpful when you want to collect and study these bugs. There is the question of Cerbana, if it's included in Phloeidae, in Plymptotomidae, if it's an entirely separate lineage or whatever. And the phylogenetic relationships of the neotropical Phloeids were undetermined at the very least. So we had farming goals to characterize family, genera, and species, update the distribution, test the classification both of Cerbana, and propose a phylogenetic hypothesis for the family as a whole. This first part is already published. I'm going to speak very briefly and move on to the phylogenetic part. So we provided new diagnosis and identification keys for both genera and species. So we hope that now the limits between the species and genera are not as blurred anymore. We also found several specimens which presented an interesting chromatic variation in Phloea subquadrata. So in this first photo, you see the specimens which you commonly have in the entomological collections, but we also found specimens with these two patterns, and this last one especially is very beautiful, has some growth rings like, and we examined their genitalia and so on, and checked that they are only the same species with chromatic variation. We updated the distribution of all three neotropical species, mainly using collection and citizen science data from the website iNaturalist. So here you can see an example for Phloea corticata. The gray triangles, which are not very easy to see, are the data that was already published. It's a very low percentage, and the red circles and blue squares are the new data that we added. The blue squares being material that we saw in collections or received the photos from other collections. And the red circles are data from the iNaturalist website. We greatly expanded the knowledge on this distribution, and we were also able to confirm the first records for French Guiana. For the other species of Phloea, it's almost the same case, except that they are distributed southwards of Phloea corticata, and we were also able to confirm the first record for Argentina. And Phloeophaena has a more restricted distribution compared with Phloea, but also represented lots of new records. And this all has been published earlier this year, so you can take a look. We went into full details on the taxonomic, morphological parts, and so on. And as for the classification, we have two competing hypotheses in the literature. These are the only works that have included both the neotropical species and Cerbana. Grazia and colleagues in 2008 recovered Cerbana always included within Pentatomoidea, Cerbana always included in Phloeidae obviously always included in Pentatomoidea, but their position varied greatly depending on the parameters, the nature of the data, and despite they used morphological and molecular data, they did not have sequences for all species. And 2 years ago, Rockacousex and colleagues published a phylogeny which recovered Cerbana within Pentatomid, and the Phloeids were grouped with the Plataspirids and Scutellarids. So we have two competing hypotheses, which are summarized in the two most widely used textbooks, at least for the pentatomoids. So are Cerbonines Phloeids? Are they pentatomids? Are they something else? We currently do not know. So to try to address this question, we performed a phylogenetic analysis using morphological data from 12 families, more than 70 species. I think we amounted to more than 120 characters. Obviously, we included all three species of Phloeidae plus Cerbana. And besides the contribution to the classification itself, we also reanalyzed the morphology of the female genitalia in the sense of what was published by Zhu and Hede in 2020. And what we did was apply modern terminology to many of the structures which, in our vision, were not exactly correctly interpreted in the last few works that dealt with it, be it Grazia or works from the 20th century. So here's an example from the flights. So back there, what they indicated as the valvifers 9, we interpreted as the thickening of the vaginal intima, and the valvifers would actually be this pointed by the red arrow, which is in turn shaped as a rod. And here's a comparative image of the flight with two non-related lineages, but just to give an example of the homologies. And to the results of the analysis, here are the trees, or better saying, the tree from the equal weighting analysis. We performed everything on TNT. So we recovered every single family. I did not put it here, but we had high support for every family, and Cerbana was always recovered at the base of Phlade, a sister group of the other three species. However, almost all pentatomoids were recovered in a huge polytomy. So here are all pentatomids, the lower or the parts under the rest of the other phylogeny. And on the implicit weighting, we found the more stable trees to have this topology. So just to show you again, we recovered every single family with high support values. Here are the flights with almost 100 on each. We used GC frequencies and related Bremer sports. And despite they also being in a polytomy, it was much more resolved. So we had on one side flayed, on the other scutellarids, and on the other a large clade composed of sigenids, acanthosomatids, dinidorids, and all the pentatomids, which occupied most of the phylogeny. Here, zooming in on the part of the flights, I think everyone's familiar with the black and white circles, but just to show you how high the supports were for the inclusion of Cerbana within Fledge, and that we have several non-homoplastic synapomorphies also. So no matter what parameter we use, no matter what we did, we always recover this relationship for the family. So the main conclusions of what we have now, or summarizing what we already know about the flights so far. This first part is what's published, so we provided some taxonomic corrections, diagnosis, key, described new chromatic variations, and the distribution was updated with a lot of contributions from citizen science. And this part is, of course, not yet published, but we are hoping to do it soon. Cerbana always grouped with the other flags with high support values, but the phylogenetic relationships are still undefined. We have some clues, maybe a possible relationship with scutellarids, as suggested in the last work of Rokakuzaks and colleagues. Perhaps not, but Cerbana always grouped with the other flags. And finally, we have the where to go part. It's not really that big, but there's a lot to do. So we need molecular data for all four species. In an ideal scenario, we would have phylogenomic data for all four species and a lot of others from the pentatomoids to compare and do some analysis. And of course, we need to combine the morphological data sets, all these characters that were reunited, reinterpreted with the molecular data. We hope to have it soon. And also there are still a lot of distribution gaps, some populational questions which are possible to investigate once the species have their limits well set. So this is not really the last slide. I have one more that I want to show you, but I would like to thank every single collection that received me as a visitor, that sent me material, data, answered my questions. I would like to thank the team also for inviting me to this talk. And finally, they are still wanted, especially if you have flights from the Amazon region or from northern Argentina, southern Paraguay, maybe. If you have any of these bugs in your collections, please send me a message. We can try to figure something out. As I said, we used a lot of data from citizen science platforms, and recently two very interesting records emerged. one from Peru and one from Ecuador. That was really unexpected, but I'm trying to contact the authors. So if you have something in any part or anything else that you find interesting and unusual about these books, please write me a message. I would be very pleased to talk about them all day. Thank you.
Thank you very much, Guilherme. I really enjoyed the talk. They're super cool bugs. Um, I have 100 million questions, which I'm not gonna ask you right now.